Hello guys, welcome to my YouTube channel and I hope that you will be really fine this day. Today I'm gonna make you learn how to make a BCD to XS3 converter using the max or multiplexer. So first you should understand this table. Here are the BCD inputs of 4-bit values that we are taking from this side. And there are the XS3 codes which are denoting W, X, Y and Z. So actually XS3 is the value that are added in the binary value with the number of 3. For example, if we have 0, 0, 0 and 0 logic states, so the output with 3 will be appear whose value in binary form is 1 and 1. Same as if 1 is given to some input, then the value of the 100 like 4 will be appeared. So as you can see that here are the BCD inputs and here is the XS3. So we have to just make it with the help of a mux. Here is a mux whose IC number is 74151. So I've created the 3 mux and the 4th mux is Z mux, and it is generally the NOT gate. I will let you know how I implemented only NOT gate instead of constructing or using the IC in the place of that. So here you can see that there are the suitable combinations for that. First I'm going to show you there. Here are the inputs that we will take in the max. So first if we go towards the W is equals to 0, here you can see that W is equals to 0 and 0. All the inputs in these two rows will be equals to 0. And the second one is X is equals to D, which is equal to X equals to 0, 1. That is similar to the column of 0, 1 for D. And then we will see that here the Z is equals to the opposite of the D column, so you will replace it by the D's complement, same as the Y will be equal to the opposite of the D, so you can also convert into the D complement. Same, the procedure will be repeated with the above below 5 values. You can see that there are 5 inputs that are being taken in the each mux. So here you see that here is W is equals to 0, W is equals to 0, W is equals to 1, and W is equals to 1, and W is equals to 1. 0, 0, 1, 1, and 1. So we will take the values here 0, 0, 1, 1, 1. So here is the implementation of the entire circuit. You can also draw it from the side. So if you see towards the value of logic states of Z mux. So here all the Z mux is equals to D dash, here also D dash, D dash. So all the columns and the rows are filled with only D dash, so you can only replace it with the D input, and then so all these 3 mux will be appeared here from the table. As you can see here that the Z is same in all the rows, which is equals to D. So we will take only the place only the NOT gate with the D, so as to represent it with the D NOT. So I'm not using this 4 mux. You can also use it, but it makes the circuit quite easier and easy to solve. So I'm just going to show you the outputs for this. Here I'm going to simulate it, and then you can see first I'm going to use the first logic state in which all the inputs are A, B, C, D are equal to the 0 logic state or the low level state. So the XS3 output should be 0, 0 and 1, 1. So here I'm just going to zoom it and let you show here is appearing 0, 0 and 1, 1. So let's take the random value. Let's suppose I take 0, 1 and 0, 1. So 1, 0, 0, 0 should be appeared at the WW. So let's check here 0, 1 and 0, 1. So here you can see that 1 triple 0 is appearing here. I'm just going to zoom it here. Okay, so next you will see 1, 0, 0, 1. So at this logic state we will see that the value appearing here is 0, 1, 0, 0. That is similar to that 0, 1, 0, 0. So after comparing it with these values, you can see that I've created the mux BCD to XS3 converter using the mux. So here is the work for today, and if you really like this video and enjoyed it a lot, so don't forget to give me the big thumbs up and press the red button below.